Hello everyone, we are group 1 presenting our project for the assignment on Arduino design project. Here you can see the push button subsystem. When we increase or decrease the slider, the analog value corresponding to the voltage changes which will be fed into A0 analog pin. This is the EEPROM flash button subsystem. The EEPROM value will be set to 0 whenever we press this button. Here is the subsystem containing the DHT11 humidity and temperature sensor, which is powered by 5 volt, and the output data will be fed as a digital input to the microcontroller. LCD screen subsystem is simulated here. We are showing humidity value, temperature value, our set threshold by the potentiometer, and the EEPROM counts by this LCD screen. Here is the PIR sensor which is used to turn on off the LCD screen. The output will be given to the Arduino at pin 2 as a digital input. We are setting the logic level here manually while the simulation runs. Here are the digital and analog outputs of the system. We are using pin 5 to give PWM output to the LED 2, which will be changing intensity according to the humidity value. And whenever the room humidity level surpasses the threshold value, the LED 1 will be lightened up, which indicates the humidity level is at a critical level. I have added the oscilloscope to show the PWM output as here. We will be using a Arduino Uno board as the microcontroller in our project. The serial monitor will be used in our testing phases. As shown here, we will upload the .hex file of the Arduino firmware to the simulation.
Now, we hope you have a good idea on the various subsystems of our project. Let's simulate the project and check the activity of each component. When we run the project, you can see the serial monitor and the oscilloscope as here. The serial monitor shows the testing value outputs and the oscilloscope shows the PWM output of pin 5, which is connected to LED 2. The count value 7 shows the value saved in EEPROM. Humidity, temperature, analog read of the potentiometer and the EEPROM value is shown in both LCD and in the serial monitor. Observe the set value 51 as here. The PWM is based on humidity value of DHT11, whereas in this scenario 70. It will be mapped into 0 to 255, which is 178. You can see that when I increase the potentiometer value, the analog value gets increased as well as the set value threshold get increased. It is now turned from 51 to 71. Let's increase this value to 81. When I increase the humidity of DHT11 sensor, you can see that the value in the monitor of DHT11 got increased. Now let's set this value to 82, which is above the threshold. We have given a delay of 5 seconds, and after the delay, the LED 1 will get lit since the value of that humidity is 82 and it is over the set value which is set by the potentiometer by us. You can observe the LED 1 get light. And also you can clearly see the EEPROM count got increased by 1 from 7 to 8. When I decrease the humidity to 80, after the delay, the LED 1 gets turned off. And then let's set the value again to 82. After the delay, the LED 1 will be turned on again. You can see the dim of LED 2 as here. So after this delay, the LED 1 gets turned on again. And at the same time you can observe the value of count get increased here. Let's stop the simulation and check the working state of EEPROM. When I run the simulation again, you can see the count of 9 plus 1, which is 10, for the counter state which has been identified by the program. 9 was the previous value and plus 1 is depending on the LED being turned on right now. The counter shows 10 as the output which is saved in the EEPROM. When I push the EEPROM flush button, you can see that the counter value got turned into 0, which shows that the counter got reset again. When I start the counter again, the counter will be turned on 1 based on the LED 1 got turned on again. When the PIR trigger signal is turned off, you can observe the interrupt code is running and the LCD is turned off. Here you can clearly see the interrupt firmware. Our objective in real life was to stop the LCD power consumption and light only when a person comes near